Hi friends, this is a second video on CAR Dent resistance. In my first video you see CAR Dent resistance little bit formula, but now in second video we going little bit deep to understand how you are selecting material and car design. So this is a second videos and look here little bit deep. Friends, if you design a car or selecting material, then 2 points are considered in mind. The first one is low energy impact, that is known as dent resistance, okay, and high energy impact, that is the crash. If you having the here high impact energy, this is a crash the car and this is a crash performance. So here low impact energy is dent resistance and here high impact energy is a crash performance or crash. So we talking about here in my first video you see this formula R dent resistance energy directly proportional to yield stress square multiplied thickness to the power 4 divided by stiffness, panel stiffness S. So after modification we talking about here, if you want to remove proportionality limit, then you need to a proportionality constant, and here constant is a K. So R dent resistance energy equals to K multiply yield stress square multiply thickness to the power 4 divided by stiffness K. And if you want to calculate stiffness, then it is a E Young modulus multiply thickness to the power A, that is the exponent, and A is also known as power adjustment of thickness, okay, because its value is vary 1 to 2. This is a power adjustable. And H is a shape factor, friend. This formula is known as Kalpakjan, okay. Now you keep in mind, after selecting material, the method is used SB's method, okay. This method is given 3 categories. The first one is dent resistant energy. Now the second one is low embodied energy Q, and here third one is light panel weight, that is a M mass. So first method we talking about here. Now we talking about second and last third one point. Now the friends, first point is considered here, we discussed already. Now the second point, low embodied energy, how can you consider? Friends, if you design car or selecting material, then these 3 points keep in mind, and the first point is we will be discussed already, and now we here talking about second point and later third one. So the second point, embodied energy, if you calculating energy content, then it will be equals to mass multiply embodied energy. What is embodied energy? It is the total energy which is produce any parts, okay, total energy content. So mass multiply embodied energy Q, and you know density rho equals to mass divided by volume, and if you calculating mass, then it will becomes rho multiply volume, and here rho multiply area multiply length, and area equals to width multiply thickness, and that is a L length, okay. W is the panel width and L is the length, panel length, and T is the panel thickness. This is a panel density. So if you M equals to these values putting here, then we got Q equals to rho WTL multiply embodied energy. So adjustable power A, if you putting A equals to 2, because adjustable power thickness, A is the adjustable power of thickness. So if you putting A equals to 2 for rectangular panel, then we got, so stiffness equals to E multiplied T square, because here S equals to E multiplied T to the power A, and we adjust A equals to 2. So H, and after calculation this replace S here and R here, then we got S equals to K sigma square T to the power 4 divided by Dent resistant energy. And after calculating T, we got in square root EHR safe factor multiplied Dent resistance energy divided by E sigma Y square. This is a formula for considering low embodied energy in form of thickness. Here friends, now we go in deep. S equals to K sigma Y square T to the power 4 divided by R Dent resistance energy, and S equals to this formula, A equals to putting 2, then we got T square to T square, here T square remain constant. So what E H and here R equals to K sigma Y square T square, and after getting T values, you got this formula. Friends, if you want to eliminate T for getting embodied energy, then you got embodied energy Q equals to M multiply Q embodied energy, then energy content Q equals to WL divided by in square root K divided by H multiply under root R, here under root R, and Q rho Q in under root E divided by sigma Y, that is the yield stress. So this is the energy consideration formula. Now the third point is light panel, that is a mass consideration. So here, if you taking material with largest M, then the formula will become yield stress divided by rho Q in square root E. So this is the 3 points we considered: the energy, mass, light panel, and the dent resistance energy. 3 points are considered here. Thank you.